Good morning, students. Our today's topic is Gauss law, or you can say Gauss theorem. So, Gauss law states that when the charge is at the center of sphere, the electric field is everywhere normal to the surface and constant in magnitude. This is actually the statement, not the statement. So, Gauss law, what does the Gauss law say? Gauss law said that total flux over a closed surface is 1 by epsilon times the charge contained in that surface. That is the Gauss theorem. So, before discussing the Gauss theorem, we have to know about the electric flux. Electric flux means what? Total number of electric field passing through an area. That is called electric flux. It is denoted by phi E. So phi E is equal to E dot ds. E stands for the electric field and ds stands for the area. So phi E, that is electric flux, equal to EDS cos theta. Here theta is the angle between E and ds. So this is the mathematical form of electric flux. So phi E is equal to EDS cos theta. This is the mathematical form of electric flux. So when we consider a closed surface, then phi E would be equal to line integral of E dot ds. So in which case this term line integral is taken, this is taken for the closed surface. This is taken for the closed surface. Okay. So according to Gauss theorem, total flux over a closed surface phi E, that is equal to line integral of E dot ds. This is the actual form of flux over the closed surface, and according to Gauss theorem, this phi E is equal to 1 by epsilon times the total charge contained by the surface. So mathematical expression of Gauss theorem will be like this: phi E is equal to line integral of E dot ds is equal to 1 by epsilon times of q. Now, let us discuss the Gauss theorem again. Say, we know that phi E is equal to line integral of E dot ds, or you can say E dot dA also. So it is line integral of E ds cos theta. Now if ds and E are acting in the same direction, then it is E ds cos 0. Now value of cos 0 is 1. So it is line integral of E ds. Now E comes out as a constant term. So phi E is equal to E line integral of ds. Now, we know the value of E. E is equal to 1 by 4 pi epsilon naught q by r square, right? And suppose the closed surface is nothing but the spherical surface, so line integral of ds is obviously equal to 4 pi r square. So if we put the values of E and line integral of ds in the first equation, the equation will be like this: phi E is equal to, in the place of E, we write 1 by 4 pi epsilon naught q by r square into line integral of ds, that is equal to 4 pi r square, right? So 4 pi and 4 pi cancelled out, r square cancelled out. We ultimately get phi E is equal to 1 by epsilon times of q, and that is the Gauss theorem. In this way, we can prove the Gauss theorem mathematically. Now, Gauss law for arbitrarily shaped surface. The net electric flux is the same through all the surfaces. See the surface here having the area A1, A2 and A3. So the net electric flux is the same through all the surface. It is seen that total electric flux is same for the closed surface A1, A2 and A3. So Gauss law states that if a charge Q is enclosed by an arbitrary closed surface, then the total electric flux phi E through the closed surface is given by this relation: phi E is equal to line integral of E dot ds equal to Q net by epsilon naught. Here Q enclosed denote the charges inside the closed surface. Now we start discussing about the applications of Gauss law. There are several applications of Gauss law. The first one, electric field due to an infinitely long charged wire. Let us consider an infinitely long straight wire having uniform linear charge density lambda. What does it mean? See, linear charge density is lambda. That indicates that lambda is equal to charge q by length L. Lambda is the linear charge density. Its mathematical formula is q by L, charge per unit length, and its unit is coulomb per meter. So the electric field at the point can be found by using the Gauss law. Okay, now let us explain this. Suppose this is an infinitely long wire. It is a infinitely long wire and it has certain amount of charges. Now around this closed wire, around this infinite wire, a closed Gaussian cylinder, this one is the closed Gaussian cylinder, is considered. Now you see this Gaussian cylinder having the length L, and there are three surfaces. One is upper circular surface, this one. lower circular surface, this one, and this one is curved surface. So three surfaces are there. Now you see, suppose in this surface, this is the direction. Let us consider this is the direction of the electric field, right? And surface, upper surface. So area is acting in this way. Let us consider this. This small area is considered as ds1, right? So here E and ds1 are acting perpendicularly. Another area is there. It is along the curved surface area. It is in the same direction of the electric field. Let us consider this area is ds2. So ds2 and E are acting in the same direction. And you say the lower surface area, let us consider it is ds3. Now you say this is the direction of the electric field and this is the direction of the ds3. So ds1 and ds3 are acting perpendicular to the direction of the electric field. So in these two cases, theta is taken as 90 degree, whereas in the second case, ds2 is the acting in the same direction as A. So here theta is taken as 0 degree. Is that clear? So the the wire is enclosed by a Gaussian cylinder having three areas. We take three small areas over there, ds1, ds2 and ds3. Here diagrammatically we show you that ds1 and ds3 are acting perpendicular to the E, that is theta equal to 90 degree, whereas ds2 is acting the same direction as E. Here theta is equal to 0 degree. Okay, now we just discuss it over here. Now you see the total flux phi E, that is equal to line integral of E dot dA or ds. So we already tell you there are three surfaces, right? So phi E can be written as E dot ds1 plus E dot ds2 plus integrating E dot ds3. If you add this 3, we will get the total flux. Now, phi E is equal to integrating E ds1 cos 90 degree. I already told you upper surface is acting perpendicular to the direction of the electric field. Here E ds2 cos 0 degree. The second curved surface is acting in the same direction as the electric field, so angle is 0 degree. So it is again E ds3 cos 90 degree. Lower surface is acting perpendicular again. So the first two, cos 90 is 0. So phi E is obviously 0 plus E ds2 cos 0 is 1 plus 0, right? So it is phi E is equal to integrating E ds2. E comes out as a constant term, integrating ds2, ds total surface area, it is a curved surface area of the cylinder, so it is E 2 pi RL. Here the height is L. So phi E is equal to 2 pi RL. Okay. Now, you see, according to Gauss theorem, we get phi E is equal to integrating E dot dA, that is Q enclosed by epsilon naught. So you see the equation, you already know that Q is equal to lambda L. Lambda stands for linear charge density. The equation will be like this. E integrating dA equal to lambda L by epsilon naught. Again, you see this formula. We already find it out. E into 2 pi RL, that is equal to lambda L by epsilon naught. From here you get E, and that is equal to 1 by 2 pi epsilon naught lambda by R. And this is the electric field for a infinitely long wire. Today is this much. The next will be discussed on the next class. Thank you.